So the next video is on D and F block elements. In D and F block elements, to solve the questions, you should know few aspects like electronic configuration of at least 3D series, that is for the element with atomic number 21 to 30. You should know the oxidation states of it. You should know which exhibits the highest oxidation state. You should know the concept that if they contain unpaired electron, they are paramagnetic in nature and their magnetic moment can be calculated by using the formula mu is equal to root of n into n plus 2 unit Bohr magneton represented as Pm. Then based on the number of unpaired, where n is unpaired electron, and based on the number of unpaired electron, you can calculate its magnetic moment. If it does not have an unpaired electron, then we say that they are diamagnetic in nature. Then, based on the presence of an unpaired electron, they have the ability to undergo DD transition. And since they undergo DD transition, they exhibit color. So, unpaired electron is necessary even to exhibit color. As well as the presence of some ligands are also responsible for giving color to the D block elements, about which we will discuss in coordination compounds. Even you should know that D block element form alloys. They exhibit variable oxidation state. They form different kinds of oxides which may be acidic, basic or amphoteric, and two important compounds, that is potassium permanganate and potassium dichromate. Their preparation method as well as they act as both act as oxidizing agent, and some of the reactions which are given in NCERT, you have to refer them. And similarly about F block elements, about lanthanides and actinides, differences between them, highest oxidation state exhibited in them, and the common oxidation state exhibited by both lanthanide and actinides, that is +3, and uses of them, and why do they form alloy. So this basic few concepts you should know, and you can study it from NCERT before you solve these questions. So we'll go with the questions now. The first question is the electronic configuration of element with atomic number 24 is, so they have given Z value 24. So the element with atomic number 24 is chromium. Electronic configuration of chromium is argon 3d5 4s1 instead of 3d4 4s2 because of the stability of half-filled d orbital. And the correct answer here given is option B, that is 3d5 4s1. Then the second question, electronic configuration of a transition element X in +3 oxidation state is argon 3d5. What is its atomic number? So it's very easy to find out. Argon means it has 18 electron, D5 means +5 electron, and +3 oxidation state means it has lost 3 electron. So 18 plus 5 is 23, 23 plus 3 is 26. So here the atomic number of the element X is 26, which is nothing but iron. Similarly, if we go with the next one, the element showing oxidation state +7 is, so if you consider chromium outer shell electronic configuration is 3d5 4s1, maximum it can lose 6 electron and hence maximum oxidation state is +6. If you consider manganese, electronic configuration of manganese is 3d5 4s2, so maximum oxidation state exhibited here is +7. If you consider cobalt, it is having the atomic number as 27, and if you consider its electronic configuration as is 3d7 4s2, so maximum here cobalt also can exhibit oxidation state of +3, and vanadium, atomic number of vanadium is 23, so its electronic configuration is 3d3 4s2, and maximum it can exhibit oxidation state of +5. So the one which can exhibit oxidation state of +7 is option B, manganese. Next, the pair of elements which show +1 oxidation state is, so in your NCERT if you see, we study it as a 1 mark question, also important. that copper exhibits plus 1 oxidation state. Now here if you consider, you have two options with copper. Remember, copper will exhibit plus 1. Along with it, even chromium exhibits plus 1 oxidation state. So here the correct answer is option C. Next, question number 5. D block element form colored ions. So the necessary condition for D block element to form colored ions is, the first necessary condition, presence of unpaired electron. It should have an unpaired electron in d orbital, and because of that electron in d orbital, it has a tendency to undergo dd transition, and during that dd transition they acquire some energy, that is absorb some energy. dd transition means from one d orbital to another d orbital the electron jumps, and those two orbitals you'll study further, we call them as T2G and EG orbital based on the type of complexes. Thus, we say that the d block elements form colored ions because they absorb some energy for dd transition. So option C is the correct answer. Next, question number 6. Cuprous ion is colorless while cupric ion is colored. So cuprous ion means copper is in plus 1 oxidation state. Cupric ion means copper is in plus 2 oxidation state. Now cuprous ion outer shell electronic configuration becomes 3d10, and cupric ion electronic configuration becomes 3d9. If I represent a d orbital here for cuprous ion, in d orbital it has 10 electrons. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means it is completely filled. But if you consider 3d9, that is for cupric ion, we see that here you are having 1, 2, 3, 4, 5, 6, 7, 8 and 9. So only one unpaired electron is present in d orbital, and due to that unpaired electron it exhibits color. So here it is having completely filled d orbital, here incompletely filled d orbital, and that incompletely filled d orbital gives color to the cupric ion. So when we look at the correct answer here is cuprous ion has complete d orbital and cupric ion has incomplete d orbital. So the correct answer for this question is option C. Next, question number 7. A transition metal has one electron in d orbital. It's a solution. Option A is colorless, has a characteristic color, appearance of color is temporary, changes color with the time. So what they have given the information is, a transition metal has one electron. One electron means it is an unpaired electron, and due to unpaired electron it will have a characteristic color, and hence the correct answer is option B, has a characteristic color. Which of the following ions are colored? So among this, which is colored, the one which has an unpaired electron in d orbital, and as I have said you earlier, to know it which is having unpaired electron in d orbital, you should know the electronic configuration of the elements from atomic number 21 to 30 at least. If you consider copper, atomic number of copper is 29. Its electronic configuration is 3d10 4s1. Now plus 1 indicates that one electron is removed, so its electronic configuration becomes 3d. exhibit color. Hence the correct option is option D, vanadium. Vanadium in +3 oxidation state exhibits color. Then question number 9. Which of the following D block element would be paramagnetic? So they have asked you which is a D block element that is paramagnetic. It is paramagnetic if it has unpaired electron. So if we consider here aluminium, it's not a D block element, it is a P block element. Magnesium, it's a S block element. Copper is a D block element. And here if you consider sodium is also a S block element. Copper outer shell electronic configuration is 3d10 4s1, and due to the presence of this unpaired electron, it is paramagnetic in nature. So the correct answer is option C. Next, question number 10. Titanium shows magnetic moment of 1.73 Bohr magneton in its compound. What is the oxidation number of titanium in the compound? So to know this, you should know one thing, that if the magnetic moment is 1.73, it has only one unpaired electron. If the magnetic moment starts with 2, number 2, it means it has 2 unpaired electron. It is a trick to remember. If it has a magnetic moment which starts with 3, it means it has 3 unpaired electron. 4 means it has 4 unpaired electron, and 5 means it has 5 unpaired electron. So here the magnetic moment starts with 1.73, means it has 1 unpaired electron. Titanium atomic number is 22. Its electronic configuration is 3d2 4s2. Now we need only 1 unpaired electron in d orbital, that means remaining 3 are removed. So when titanium is in +3 oxidation state, we get the electronic configuration as 3d1. So here the correct answer is option C. Titanium with the +3 oxidation state will have the magnetic moment value as 1.73 Bohr magneton. Next, paramagnetism. Paramagnetism is a property of the elements or molecules containing what? Unpaired electron. So the correct answer is option B, unpaired electron. Now here with this concept, that is if the magnetic moment value starts with 1.73, unpaired electron is 1, 2.8 unpaired electron is 2, 3.8 unpaired electron is 3, 4.9 unpaired electron is 4, 5.9 unpaired electron is 5. So based on it, if you go with this question number 12, it is very simple to solve it. The question given is, a metal ion has a spin magnetic moment of 3.87 Bohr magneton. The number of unpaired electrons present is, so since the number starts with 3, the number of unpaired electron present also will be 3. Next, question number 13. The expression used to calculate the magnetic moment is, so the expression used to calculate magnetic moment is mu equal to root of n into n plus 2, where n is the number of unpaired electron and the unit for magnetic moment is Bohr magneton. Next, which one of the following is diamagnetic? The one which has all the electrons paired in it, we call it as diamagnetic in nature. So if you consider now copper plus 2, atomic number of copper is 29. Its actual electronic configuration in ground state is 3d10 4s1. Due to the removal of electron, its outer shell configuration, you get it as 3d9. Whereas in case of zinc, atomic number of zinc is 30. Its electronic configuration is 3d10 4s2. Due to the removal of 2 electrons, its electronic configuration becomes 3d10. Nickel, atomic number of nickel is 28. Its ground state electronic configuration is 3d8 4s2. Plus 2 indicates removal of 2 electron, hence its electronic configuration is 3d8. And if you consider cobalt, atomic number of cobalt is 27. Its electronic configuration is 3d7 4s2, and by the removal of 2 electron, the electronic configuration becomes 3d7. Now if you consider here 3d7, it is incompletely filled d orbital, means it has an unpaired electron. This is also incompletely filled d orbital, means it has an unpaired electron. This is also incompletely filled d orbital, it has an unpaired electron. So this has unpaired electron, so it is paramagnetic. This has unpaired electron, so it is paramagnetic. This also has unpaired electron, so it is paramagnetic. Whereas zinc ion in +2 oxidation state does not have any unpaired electron. All the electrons are paired up and it is repelled by the magnetic field, so it becomes what here? Diamagnetic. So the correct answer for question 14 is option B, diamagnetic. A molecule ion is Zn2+. The highest magnetic moment is shown by the transition metal ion with the configuration. So remember, highest magnetic moment is shown by the configuration which has highest unpaired electron. So highest number of unpaired electrons are in which configuration? We'll try to find it out. So the first one given is 3d5. So d5, we know that d orbital we can represent it by 5 boxes. According to Hund's rule, they should be singly filled first, so all the 5 electrons are unpaired. 3d2 means 2 electrons are unpaired. 3d9. Now when we consider 3d9 configuration, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 electron is unpaired. So here we had 5 unpaired electron, here we had 2 unpaired electron, here we have 1 unpaired electron, and when we say Cu plus, the electronic configuration is 3d10, so 0 unpaired electron. So greater the unpaired electron, greater is the magnetic moment, and the highest magnetic moment is shown by the configuration 3d5 as it has 5 unpaired electrons. Next, question number 16. Which of the following ion has least magnetic moment? So highest unpaired electron, high magnetic moment. Least magnetic moment means lower number of unpaired electron. So Cu plus 2. So if the element Cu plus 2 means the electronic configuration is 3d9, and hence here we have only, if you consider 9, we have already counted, we have only 1 unpaired electron in Cu2 plus. Ni2 plus, electronic configuration of Ni2 plus is 3d8. So 3d8 means when you write the electron, how many unpaired electrons you get, we'll consider here. So if you consider 1, 2, 3, 4, 5, 6, 7, 8. So 2 are unpaired. So 2 unpaired electrons in Ni2 plus. CO3 plus atomic number is 27, and in +3 oxidation state it becomes 3d6. So 3d6 means the number of unpaired electron in CO3 plus 1, 2, 3, 4, 5, 6. So 4 unpaired electrons are present, and Fe2 plus atomic number of Fe is 26. Removal of 2 electron, you get the electronic configuration as 3d6, and here also how many unpaired electrons are present? They are 4. So least number of unpaired electrons are present in Cu2 plus, hence Cu2 plus will have the least magnetic moment. Next, question number 17. Transition elements form a large number of complex compounds because they have, so 3 reasons are given in NCERT: because of small size, high ionic charge, and a presence of d orbital or availability of d orbital. So small atomic size, ionic charge will be positive there, remember it. Option A is given as small atomic size. B, small atomic size and high positive charge. C, high positive charge. D, large atomic size and high negative charge. So the correct answer and a suitable answer is option B, small atomic size and high positive charge. Question number 18. The ability of transition metals to form complexes is mainly due to, they are metal, ns orbitals are vacant, availability of d orbital, presence of active center. So the transition metals form complexes mainly due to the availability of d orbital. So these are the 3 reasons why do they form complexes, as we have discussed earlier: small atomic size, high positive charge, and availability of d orbital. Next, question number 19. Transition metals form alloys. Question number 19. Transition metals are generally used as catalyst because, they are used as catalyst because the options given are: they form different intermediate compounds. B, they are heavy metals. They are paramagnetic. Option D, they possess high melting point. So the correct answer is they form different intermediate compounds, and since they form different intermediate compounds with different oxidation states, they are used as catalysts. Then question number 20. Transition elements form alloy readily because they have similar properties, same outer electronic configurations, similar atomic radii, same incompletely filled d orbital. So the correct answer is similar atomic radii. Due to similar atomic radii, transition metal form alloys. Then question number 21. Which of the following is an amphoteric oxide? Amphoteric oxide means which can behave both as an acid as well as a base, that is react with acid as well as a base, and the correct answer for this is V2O5 and Cr2O3. So the correct answer is option A, V2O5 Cr2O3. V2O5 is amphoteric, but in solution it acts like acidic by giving ions, which is given in your NCERT textbook. But V2O5 is actually amphoteric in nature. So the correct answer is option A. Then next question number 22. Interstitial compounds are formed when small atoms are trapped inside the crystal lattice of metal. Which of the following is not the characteristic property of interstitial compounds? Option A, they have high melting point in comparison to pure metal. They are very hard. They retain metallic activity. They are chemically reactive. The first three are the properties shown. The fourth property, that is they are chemically very reactive, is the incorrect property of interstitial compound. Hence the correct answer is option D. The correct property would be they are chemically inert. Instead of inert, they have given very reactive. That is why the correct answer is they are chemically very reactive. Next is question number 23. The magnetic moment is associated with its spin angular momentum and orbital angular momentum. Spin only magnetic moment value of Cr3 plus ion is. So Cr3 plus, that is chromium. Atomic number of chromium is 24. Cr3 electronic configuration of outer shell. Electronic configuration of chromium is 3d5 4s1. Removal of 3 electron, plus 3 means removal of 3 electron. So the resulting configuration here becomes 3d3. So n value is 3. So when you calculate mu is equal to root of n into n plus 2. That is 3 into 3 plus 2. 3 plus 2 is 5. 5 3s are 15. That is root 15. Root 15 value, you get it as 3.87 Bohr magneton. So the correct answer here is option B, 3.87 Bohr magneton. Next question number 24. MnO4 minus acts as an oxidizing agent in alkaline medium. When alkaline KMnO4 is treated with potassium iodide, iodide ion is oxidized. Iodide ion is oxidized too. So what they have given here, in alkaline medium, if they give acidic medium, iodide is oxidized to iodine, but in an alkaline medium, iodide is oxidized to iodate, that is IO3 minus ion. So the correct answer is option C. Then question number 25. Which of the following statements is not correct? So here if we see, copper liberates hydrogen from acid, it's not possible because copper is less active than hydrogen. Copper cannot liberate hydrogen from acids. Option B, in its higher oxidation states, manganese forms stable compounds with oxygen and fluorine. So it is seen that the highest stable oxidation state of manganese with fluorine is MnO4, with oxygen is Mn2O7, and with an oxyfluoride it is MnO3F. So it is forming stable compound with fluorine as well as oxygen. So this is a correct statement. Mn3 plus and CO3 plus are oxidizing agent. That means they have the tendency to undergo reduction further. Yes, it is true, they act as oxidizing agent. Ti2 plus and Cr3 plus are reducing agent. That means they have a tendency to further undergo oxidation reaction, and hence this is also a correct statement. Which is not correct is statement 1. That is, copper liberates hydrogen from acid. So correct answer is option A. Question number 26. When acidified K2Cr2O7 solution is added to stannous, Sn2 plus is stannous salt, then Sn2 plus changes to stannous changes to stannic, that is Sn plus 4. In first PU in P block elements, you have studied that they can exhibit two different oxidation states, that is tin in plus 2 and plus 4, and plus 2 is more stable, so it changes to stannic. So the correct answer is option C, Sn plus 4. Highest oxidation state of manganese in fluoride is plus 4, but highest oxidation state in oxides is plus 7 because fluorine forms single bonds, whereas oxygen has a tendency to form multiple bonds which increases its stability. Hence, the correct answer is option D. In covalent compounds, fluorine can form single bond only while oxygen forms double bond. So the correct answer for question number 25 is option D. Next, if we go with question number 28. Although zirconium belongs to 4D transition series and hafnium to 5D transition series, even then they show similar physical and chemical properties. It is due to lanthanoid contraction. So due to lanthanoid contraction, they have a similar atomic radii. So the correct answer here is both belong to D block. Yes, but that is not the actual reason. Both have same number of electrons. No. Both have similar atomic radius. Yes, so they both have similar atomic radius due to lanthanide contraction. Hence, this is a correct reason for the above question. So, question number 28, the correct answer is option C. Next, why is HCl not used to make the medium acidic in oxidation reactions of KMnO4 in acidic medium? Why? Because KMnO4 oxidizes HCl into Cl2, which is also an oxidizing agent. Hence, option B is the correct answer. Next, in dichromate ion, the number of bonds they have mentioned here, that is, it may have 4 CRO bonds equivalent, 6 CRO bonds equivalent, all CRO bonds equivalent, all CRO bonds are non-equivalent. So when we draw the structure of dichromate, it is somewhat like this given in your NCERT. One is a bridged bond and remaining are terminal bonds. So CRO 1, 2, 3, 4, 5, 6. These 6 are equivalent, one is unequivalent. So the correct answer is option D, 6 CRO bonds are equivalent. Next, question number 31. In chromite ore, the formula for chromite ore, when we study about the preparation of potassium dichromate from chromite ore, we write it as FeCr2O4. So which is nothing but FeO dot Cr2O3. Both mean one and the same. So in FeO, oxidation state of Fe is plus 2, and in Cr2O3, oxidation state of Cr is plus 3. So the correct answer is option D, plus 2 and plus 3. Next, question number 32. Identify the product and its color when MnO2 is fused with solid KOH in the presence of oxygen. So in the preparation of potassium permanganate, whether it is by electrolytic oxidation or by the method using pyrolusite ore, which we see in both the steps, in the first step we see that it forms potassium manganate in first step, which is a dark green color substance with the formula K2MnO4, and the correct answer is option B, K2MnO4, which has a dark green color. Next, question number 33. Lanthanoid contraction is caused due to, so the reason is imperfect shielding of one 4f electron by other. So let us go with the option. The appreciable shielding, it's never appreciable, it's an imperfect shielding. So option A can't be the correct answer. Appreciable shielding of an outer electron by 5D, never 5D electrons are involved here, it's 4f electron. The same effective nuclear charge from cerium to lutetium, no. The imperfect shielding is the imperfect shielding of an outer electron by 4f electrons from the nuclear charge. So option D is the correct answer. Next, question number 34. The lanthanide contraction is responsible for the fact that zirconium and zinc have the same oxidation state? No. Zirconium and hafnium have the same radius? Yes. Option B is the correct answer. Zirconium and hafnium have same atomic radii as a consequence of lanthanide contraction. Next, question number 35. Gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is the correct electronic configuration of gadolinium? So, gadolinium electronic configuration is xenon 4F7 5D1 6S2. Its electronic configuration is 64. Xenon is 54. 54 plus 7, 61, 62, 63, 64. If you see here all will give you 64, but remember that in gadolinium it has half filled f orbital and 5d1 electronic configuration with 6s2. So the correct answer is xenon 4f7 5d1 6s2. Question number 36. The actinoids exhibit more number of oxidation states in general than that of lanthanides. This is because. So the reason for this is, so they have given 4 options, we'll go with it. The 5f orbitals are more buried than 4f orbitals. No, the 5f orbitals are away from the nucleus than that of 4f orbital. There is a similarity between 5f and 4f and 5f orbitals in their angular part of wave function. No. The actinides are more reactive than lanthanides. No. The 5f orbitals extended further from the nucleus than 4f orbitals. The correct answer is option D. The 5f orbitals, the correct and the suitable answer for the above question is the 5f orbitals extended further from the nucleus than the 4f orbital. So these were the questions regarding D and F block elements. Remaining we'll discuss, that is the remaining chapter, coordination compound and the organic chemistry chapters. We'll discuss it in the next video. Thank you for watching. Prepare well for your exams. All the best.